On this video, we're going to go through the exterior angle theorem. You saw a little bit of this yesterday, but I just wanted to talk about it, and then they'll do a few problems. There is a MyMathLab open that has 8 problems on it that deal with this. It's open until next Friday. So when you finish this, go ahead and work on that. This paper will need to go on the next page, which I think is page 57. And please don't forget to turn in your homework before you leave today that's due, please. So, exterior angle theorem, just want to go through that with you and work out a few problems. So, when you have a triangle, as in this picture right here, A, B, C, there's our triangle with angles 1, 2, and 3. If you extend the line and form a supplementary straight line, you have exterior angle. You can actually do this on any one of the angles up here, but this example has it coming off of angle 3. You could do one off angle 2, you could do one off angle 1. It would always make a straight line. The exterior angle is the one on the outside of the triangle, so angle 4 is the exterior angle. So, the measure of angle 4. So, because angle 4 and 3 make a straight line, so looking up here, these are called, right here and right here, are called the remote interior angles. And the reason they're called that is because they are not adjacent, they are non-adjacent to the angle that's the exterior. These two angles have a special relationship with this, and I'm going to go through why. So first off, let's talk about that this is a straight line. So these two have to add up to 180. Add to 180. Well, we have a triangle here too. And because we have a triangle, we know that in a triangle, the angles add to 180 also. So if we take 34 and 21, feel free to use a calculator, that's 55. That means this angle, this obtuse angle, is 180 minus 55, which is 125. Well, if this is 125, then that means x and 125 make 180. That means x has to be 55. So x is 55 degrees. Well, if you notice, this angle on the outside and the two angles on the inside are the same. 21 and 34 is 55, and the outside angle is 55. And that's what the theorem states, is that the exterior angle is equal to the sum of the two remote interior angles, the one that is not adjacent, so not the one that's next to it, that's supplementary, but the ones that are what we call the remote interior angles. So it would look like this. The measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 4. So 1 and 2 together will make angle 4. And that's what our theorem states. An exterior angle of a triangle is equal to the sum of the two remote interior angles. So the rest of these problems are just going to be using that theorem. Now you'll notice on this problem, I went ahead and found this angle, and then I found the outside angle, the exterior. You can do that when they give you the numbers. It works every time, and it's fine. But you can actually shortcut it. So for our first problem here, it says find the measure of an unknown angle. This question mark here, well, obviously it looks obtuse. Does that make sense? And if you wanted to, you could go ahead and find this, but let's kind of do it the theorem way. 70 and 50, these are the remote interior angles because they are non-adjacent to this question mark. So 70 and 50 add up to 120. This angle right here should be 120. And just to kind of prove that, 70 and 50 is 120, so this is 60. There's that straight line again, which makes this is 120. It's just quicker to take 70 and 50 and add them together. Number 2, same thing. Question mark, these are our two remote interior angles. So 28 and 58 is 86. So this angle is 86 degrees. Go through these. If it goes going too fast, just pause it and rewind it. So 35 and 95, this is on the exterior. This is also an exterior angle here if it asked about it. If this is our exterior angle, it's got a question mark for them. These are the two remote. Remember, it's non-adjacent, so this is the adjacent one. These are the two non-adjacent. And this one adds up to 130. 95 plus 35. Number 4. Here's the angle we're looking at. This is the adjacent one, so we're not going to use that. It's the two non-adjacent. This is 105 degrees. The last two are kind of going backwards. We know this is 50, and we want to make 115. Now again, if you wanted to, you could find this one easily, and that means you then could find this one. But again, you can, since we know one of the outside angle, one of the remote interior, 115 minus 50 would be our missing angle, which would give it to be 65. But again, if you wanted to, you could just add those two, take that from 180 and go from there. Same problem right here. If you wanted to, you could get this as 60, figure it out, but this is the remote interior angle, and so is this one. So we're going to take 120, and we're going to subtract away 50, and that leaves us with 70. If you just want to verify that, this would actually be 60. 60 and 50 is 110. So take that from 180, and there you do, in fact, get 70. So the nice thing about it is if you do only have one missing, you can find a missing piece. Now, if you turn to the back, we have a few that involve variables. So we'll look at those with the variables, and then you'll be able to work a few problems on your own. So we have a few problems here, a couple with just numbers again, and then we have a couple of variables. So again, here are our remote interior angles. This is our exterior, so these two should add to this. So 45 plus question mark should equal 140. So that means to find the question mark, we're going to subtract it. Looks like this angle will be 95. So our question mark this time will be 95. And again, you could find this one first if you wanted. And one last one, remote interior are here and here. Remember, it's the non-adjacent angle. This is the adjacent one, so we don't use that. This will be 110 minus 80. So this angle must be 30 degrees. And those are ones that just have numbers. The last two have a few variables. So now we just have to remember what the rule says. It says that the two remote interior angles add up to the exterior angle. So the two remote interior angles add or sum up to the exterior angle. So this is what we would get. Now we're just going to solve for x. So we have 4x plus 32 equals 8 plus 6x. And we're going to solve for x by subtracting. Looks like we're going to subtract 8. It's 24, so x is 12. Now let's just check that. So I'm going to use a different color here to check this. If I take 12 and plug and substitute back in, 8 plus 6 times 12, well, 6 times 12 is 72, plus 8 is 80. 4 times 12 is 48, plus 2 is 50, and 50 plus 30 is 80. That's our two remote interior angles add up to our exterior. And one last problem. Here are our two remote interior angles. They will add to our exterior angles, to our one exterior angle. That's what our theorem states. And then we'll just solve for x again. Subtract 5x. And we'll subtract 2 to the other side. Looks like we have 6x on this side, and it looks like we have 66 here. So x is 11. Now, anytime if this video got going too fast, just pause it or rewind it and watch it again. Let's just double check everything. So if we plug 11 back in here, substitute, that's 55 plus 10 is 65. 11 in here is 121 plus 2 is 123. 65 plus 58 is 123. So the rule is the exterior angle is equal to the sum of the two remote interior angles, the non-adjacent angle of the triangle. Now one more time, you have a MyMathLab that has 8 questions on it that deal with this. Please don't forget to turn in your homework before you leave. This paper will go on the next page in your notebook.